Hello all, welcome to Chemistry EduHub channel. Today we are going to talk about the concept of orbital. So earlier we have studied Bohr's theory, where Bohr said that electron will be revolved in an orbit. Orbit is a two-dimensional path, whereas orbital is a three-dimensional path, which is contradictory to that of the orbit. So mainly this orbital concept is obtained from probability concept, because what is an orbital? The definition is the region of space around the nucleus where probability means you can say that the possibility of finding an electron is maximum. That means such region is called orbital. That means if this is the nucleus, Bohr said that this is an orbit where the electron is revolving, but the orbital indicates that there could be some region which is a three-dimensional path. In this region, the maximum probability of finding an electron is present. So you can find the electron in certain region. Such region is called an orbital. Now, each orbital in an atom each orbital is defined by three quantum numbers. What are they mainly? N, L and M. Spin quantum number is also required, but mainly these three quantum numbers can define the position of an electron in each orbital of an atom. So in the orbital also there is some region where you do not find any electron. Such region is called nodal plane or nodal region. What is nodal plane or nodal region? The region or the plane is a line that you draw. Okay, region or plane where probability of finding an electron is 0. That means you do not find an electron in the nodal plane or nodal region. In orbital, you can find the electron up to 95% or maximum probability is present. So we need to learn the shapes of orbitals. So if we draw three-dimensional surface around the space where the probability of finding an electron is maximum, suppose if this is the nucleus, if you imagine that this is the region where the probability of finding electron is maximum, then we draw a three-dimensional path using the probability distribution curves. You can say probability curves. So by using these curves, we give different shapes for the orbitals. So if L value is 0, then the shape of the orbital is considered to be spherical, and we represent that orbital as s orbital. So in the first shell, you find only s orbital and you call it as 1s orbital. Now this orbital will have the spherical shape because the electron is distributed evenly in all direction. Electron is distributed evenly in all directions possible. So hence the shape of the s orbital is spherical. For 1s orbital, the electron distribution, if we consider, this is the central nucleus, and around the nucleus you see the region where the probability of finding electron is this. This is the region where you can find the electron to up to 95%. This is the shape of 1s orbital. For example, if you consider the 2s orbital, the shape is spherical, but you find two such lobes. Since it is 2s, this is one region and this is one region where the electron probability is maximum in these regions, The orange part is the orbital, and in between whatever zone is there or the region, that is called the nodal plane or nodal region, where the probability of finding electron is 0. And as the n value increases, the size of the s orbital also increases. Size of the s orbital also increases because the distance between the nucleus and the outermost orbital or the shell increases. Next comes the shape of the p orbital. So for a p orbital, the L value starts with 1. So L value is 1 because the n has to be 2. N is 2, L has to be 1 for p orbital. So then what will be the m values? It will be -1, 0, +1. That means the p orbital can be distributed in 3 different orientations. So what does p subshell has? P subshell has 3 orbitals. What are those 3 orbitals? They are px, py and pz orbitals. Now what is this xyz? It is the distribution of electron along xyz axis. And what is the shape of the p orbital? Dumbbell shape. That means dumbbell shape. That means the electron density is distributed in the form of 2 lobes this way. Based on the probability distribution curves, the electron axis is distributed in the form of 2 lobes. So for example, if you consider px, for px, the electron density is along x-axis and yz will be the nodal plane. This is the nodal plane. And for py, along y-axis you find the electron density, and whatever x and z axis is there, this is the nodal plane. And similarly for pz orbital, y and x axis will include the nodal plane. So this way we represent, this is px, this is py and this is pz. So based on that, 3 different orientations are possible. Next is the shape of d orbital. So for d subshell, the L value is 2 and the m values will be 5, that is -2, -1, 0, +1, +2. That means this can be arranged in the 5 different ways. So d subshell will have 5 d orbitals and those are represented as dxy, dyz, dzx, dx square minus y square and dz square. So based on the electron density distributed, the shape of the d orbital is called double dumbbell because it has the electron density distributed in 4 lobes and hence it will have, each d orbital will have 2 nodal planes. So let us see the shapes of these orbitals. So for the dxy orbital, dyz and dzx orbitals, the electron density is distributed in between the axis. If this is the axis, this is in between the axis. So dxy, dyz, dzx are in one form, and dx square minus y square and dz square have the electron density along the axis this way. The shape of all the 4 orbitals is double dumbbell, but dz square is like a donut shape where the electron density is along the axis and also at the center it is like a ring formation. So these are the 5 orbitals possible, and all these 5 orbitals are called degenerate orbitals because their energy is same. Energy is equivalent or same. The same way all the p orbitals are also degenerate and equivalent. So this is about the spd orbitals and its shape. Then if you consider f subshell, it will have 7 different arrangements, but the structures are even more complex than d. We can expect questions like draw the shapes of spd orbitals for 1 mark, 3 marks or 5 marks, but most important question that can be expected in this topic is the differences between the orbit and the orbital. So what is an orbit? It is a circular path around the nucleus where the electron is revolving. This is the orbit. But what about the orbital? It is a space around the nucleus. If this is the nucleus, it is a space around the nucleus where the probability of finding electron is maximum. That is simply the definition of orbit and orbital. And this is a two-dimensional path where you can see only xy plane. But this is a three-dimensional, orbital is a three-dimensional path where you can see all the three x, y, z axis. Then orbitals are circular in shape. Orbits are always circular. Whatever number of orbits are there, all are circular. But orbitals have different shapes like spherical, dumbbell, double dumbbell, etc. Then in each orbit, the number of electrons accommodated depends on the n value, 2n square. Like first shell has 2 electrons, second shell has 8, third shell has 18, etc. so on. But an orbital will always have only 2 electrons. The maximum electrons in an orbital is only 2. One with upward arrow, one with downward arrow. And since orbit is a two-dimensional path, you can find both position and the velocity of an electron. But since orbital is a three-dimensional path, it is not easy for us to calculate both position and velocity. We can either find out the position or the velocity, but not both. This is about the orbitals and the shapes of orbitals concept. If you write these 5 points for 5 marks, you are going to get 5 marks for sure. Thank you.